Hello everybody. Today I am going to take another session in engineering mechanics. That is the first session in the chapter called as centroids. In this chapter we will see what is a center of gravity, what are centroids, how they are found out or how they are determined, and we will see some basics how on what principles these centroids are determined. These are the things which we are going to cover in this session. We have seen what are forces, what are moments. We define force as an agency which changes the state of a body. That is, whether the body is moving or at rest. Then, if the body state, that is, when the body is brought to some halt or it starts moving with uniform velocity, then we call the change as force. That is, force is the change that brings out in the state. And we have seen what is movement. Force has two effects, that is, it can translate and it can rotate depending upon the point of application of the force on the body. If the force is applied at the middle of the body or near the centroid of the body, then it translates the body. When it is applied at a distance, some perpendicular distance, then there will be a turning effect of the force, which we call it as moment of force or simply moment. So we have seen how to suppose if some parallel forces are acting on a body, then what is the net effect of the moment. We have seen that if some parallel forces are acting on a body, we simply add them algebraically so that we get the resultant. Resultant of force is sum of the forces acting parallelly. That is, we have thereby derived the equations of equilibrium. That is, the sigma Fv is equal to 0 and sigma m is equal to 0. Therefore, the moments we get due to force may be a anticlockwise movement or clockwise movements. By adding these moments, the sum of the moments we get by algebraic addition. We have seen the principle of moments, that is Veron's theorem. Say it states that the sum of the moments due to individual forces is equal to the moments produced by their resultant. The same principle we use in getting the centroids or unknown centroids of a figure. So before we go into the subject, we'll see the basics of the subject. That is, what are centroids and what is the necessity of centroids. So finding center of gravity or centroid, we will know what is the difference later. We need for designing of the structures, that is, to know where the entire force is acting, to know its stability, we need to know what is the centroid and also what we call it as moment of inertia. That in the later stages we will be learning what is moment of inertia. Even for knowing the moment of inertia, we need to find the centroid. Therefore, these are very important in design, to know the centroid or sometimes synonymously we may say center of gravity, but there is a slight difference between centroid and center of gravity. So this is the first session in this chapter of centroids. With the knowledge which we have on movements, forces, we will find the centroids, and for different sections we will find what are the centroids of those sections. That is, the centroid is the point, or the it is the place where the entire body's area or weight is assumed to be active. So that point we need to find out. This is our aim, that is to find the point where which in a figure, in a 3D body, in a three-dimensional body or a solid body, what is the point, which is the point on which we have the centroid. So you might have seen some students rotating their books or their mobiles on the finger, somewhere putting the finger and rotating them. And we have seen some footballers, they rotate football on their fingers. How are they doing that? That is, indirectly they are putting their fingers on the point of center of gravity, the centroids. Suppose because they are providing some motion, they are balancing. Otherwise, without balance also, we can balance a mobile on my finger. This is how I balance the mobile on my finger, mobile phone, for example. This phone, why it is balancing on my finger? Because I could place the center of gravity of this body so that I placed my finger below that center of gravity. That is why they are equally balanced and the mobile is stable. If I put my finger somewhere near the end, I cannot balance this mobile phone. So to balance a mobile phone, I am finding the center of gravity. If I consider it as a plane figure because the thickness is constant, the centroid, and I am able to balance this mobile. It is a common feature in our daily life that unknowingly we are able to find the centroids or center of gravities of the body. But mathematically or in physical science or engineering, rather engineering mechanics, we have to calculate these by using some mathematical formulae or some experimental basis. Here we go from something called as the center of gravity. As the name itself is self-explanatory, that is, it is the center of gravity. That is, the gravity is acting on this center. So, just a moment. The center of gravity is the center through which the gravity is acting. We know from our basic principles of physics, every body has some mass. That is, every body consists of some particles. Each particle has some mass. If there is no mass, there cannot be any physical body. Every body has a mass, however light it may be, but a body, to constitute a body, there should be some particles. Those particles should have some mass. And also, everything which has some mass is pulled by gravity. That is the Isaac Newton's discovery. That is the apple, the famous apple experiment or apple story, that Isaac Newton was sitting on the tree and somewhat that story goes on. So finally he found out that all the bodies are pulled towards the earth by some gravitational force. That is, whenever there is some mass, it is always pulled by the gravity. So that is why we have the weight of a body. Similarly, we say in our 10th class physics or your first year physics that mass and gravity are two different entities. That is, mass is the matter which is there in the body. So mass, whether it is here or on the moon, the mass will be same. The matter with the body, the matter in the body will be same, but the weight is dependent on the gravity. We have seen, you might have learned that gravity is not constant throughout the earth, or it is some 11 times or so lesser than earth when we go on to the moon. So the weight is dependent on gravity. Mass is constant. Weight, what is the relationship between weight and mass? So weight is equal to mass into gravity. So any body which has some mass has some weight because there is some gravitational pull. When we divide a body, an entire body into small particles, each particle is having its own weight, and each particle is pulled by the gravity. Therefore, weight of each particle is mass into gravity. Since the gravitational pull is only through one direction, all weights are acting as a parallel forces. We can say weight and force are same. That is, weight is nothing but a form of force, because weight is mass into gravity. Mass into gravity is acceleration. Acceleration due to gravity. That is mass into mg. Weight is equal to mg means weight is equal to mass into acceleration. Therefore, force is mass into acceleration, weight is mass into gravity. They are same. So the weight is nothing but a force. So when we say weight, you should be able to think that it is a force. So if I as earlier, if I divide this mobile into several parts, each part has its own center where it can stand on its balanced. So entire all those are also standing on one point. That means the all parallel forces are having some resultant. The resultant of all forces also acts along some point. That is, individual points are acting along their center of gravities. All together also having some point, we don't know where it is. That is what our problem is, to find the center of gravity, the point where the all the forces, all the weights are assumed to be concentrated. The points through which the resultant of all four weights of particles act is called the center of gravity. The point through which the resultant of all weights or all forces of all particles acts is called the center of gravity. So center of gravity is a concept which is applicable to weights. That is, it is all the weights or all the forces of weights, or we can simply say all the weights. All the weights have some resultant because all the weights are forces. All these forces have some resultant. The point where through which the resultant is acting is the point of our interest. That is why we are interested in the point where the entire resultant of this body, that is, all these particles form the body, all these particles have their own weights acting to some points, all those weights put together are passing through some point. That point is our point of interest. That point we call it as center of gravity. That is, the all forces or all weights are assumed to be concentrated on a single point. That single point, we want to find out the location of that single point on the body. That single point has both x coordinates and y coordinates, and if it is three dimensional, also z coordinates. So from origin, what is the distance of the centroid? That is our interest. So we can define a center of gravity of a body as, just a minute. We define the center of gravity of a body is the point through which the resultant weight of the body appears to be concentrated for any orientation of the body. Here the condition is for any orientation of the body. That is, we have seen this is the centroid or center of gravity of this mobile. So for any orientation, if it is same, that is, at any angle, if I turn this to any angle, that is here, here, at any orientation, the point where the entire weight is acting is same. That point, that for any orientation of the body, the point through which the entire weight is assumed to be acting is same for any orientation. That is, it is not for one orientation. For any orientation, the body remains same. Here, if you see this graphic, that is this figure, some body is there, which is not symmetrical, which is some random shape. If we divide this body into number of parts, each part has its own weight acting through the arrows. That is, arrows are the forces or weights. So every particle is having its own weight and having the weights through their centers of gravities, or so through their individual series. So if this red arrow is resultant and the point of action of this red arrow is through some point, that is blue dot, we have seen through blue dot. So that blue dot through which the resultant is acting, that point is center of gravity, which is our interest. That is, we want to find the location of that such point where the entire weight is assumed to be acting. That is, individual particles are there, individual forces are there, individual forces are acting. Those forces, when combined together, their resultant should be acting through some point. That point is, we call the center of gravity. This point is constant for any orientation. Let us say in the next figure, we have seen the orientation is changed, the action of the arrows, the direction of arrows is changed, but they are towards the gravitational pull. Earlier, if you see, they were making some different angle. Now, depending upon the orientation of the body, these forces are acting, and the resultant is also acting to the downwards. That is the towards the gravity. So, therefore, for any rotation, for any orientation, if we rotate this body in any direction, any orientation, if we orient it to any direction, even then, the point where which the resultant is acting is constant. That point, suppose for some orientation, it may be it we have for if we have different points for different orientation, it cannot be the center of gravity. The center of gravity will be the point through which the entire forces are acting for any orientation. So if we change the orientation to any direction, the center of gravity remains same. Such a point through which the resultant acts is called the center of gravity. So you should be able to, by now you should have understood what is center of gravity. It is nothing but a point, a location, a point in the body through which the entire force or weight of the body is assumed to be acting. So to locate that point is our interest. In three-dimensional, for a three-dimensional figure, we have the coordinates of the point as x, y, and z, because it is a three-dimensional body. If we see this center of gravity of this mouse, so if we put it in x, y, z direction, some x is there, some y is there, some z is there. These 3 points constitute the center of gravity, that is the location of the center of gravity of any body. So how to find the center of gravity of a body? Initially, experimentally, they could find out the center of gravity of a body. That is by suspending a body along some axis. Let us say A is the first axis. By suspending it through A, the due to gravity it is making some vertical line. So if we this string, if we mark the direction of the string, then we will get some line A. Similarly, if we change the direction of this body and again suspend it, it will pass through some line. It has some line of action. That line, let us call it as B. So this initially it was through some straight line A, it was passing, and afterwards it is by after changing the direction it has passed through B. Similarly, again if we change the direction, it has passed through the line C. So all these 3 lines intersect at some point. Let us say this is O. So that is the centroid of the body or center of gravity of the body. That is, whenever we suspend a body, the force of action, this is the string is acting up through this line. Similarly, when the orientation is changing, it is passing through the point B, or that line is along the B, vertical line along passing through some B, and also for another orientation it is passing through C. If these 3 lines intersect at some point, if they intersect at some point at O, that O we call it as center of gravity. If we locate that point, if we can mark that point would be the center of gravity. The point of intersection of these 3 lines gives the point through which the entire load acting. So the point is called the center of gravity. we have seen how to find the centroid of a triangle in your geometry in your earlier classes. That is, we have bisected the side and we have drawn the lines through the apex. So when we bisected each side and joined that point of bisection through the apex, we get three such lines. Then that point of intersection of these three perpendicular bisectors becomes the centroid of the triangle. There we have seen, we are aware of the centroid in our earlier classes also, but it was there we have not shown much interest or much stress on that part, on that concept. Simply we wanted to find the centroid. Simply we bisected the triangle and we found out the perpendicular bisectors where they meet. That point we have called it as a centroid of a triangle. That we have done in our earlier classes. The same thing, instead of a triangle, we have taken some irregular body. That irregular body we have suspended because the gravitational force acts only vertically. That vertically, when it acts, it passes through some point A. Let us say some line A. This line, if we mark, and also another orientation, if there is some other line B, and also for another orientation, if some other point is there C, then that will be through point O. Once we know the center of gravity, we can directly find out where the entire weight acts. Similarly, suppose if we orient it to some other line D, automatically that also passes through some center of gravity. This was by doing the experiment. Every time it is not possible to suspend a beam or a large, let us say, ship to some string and see what are the different lines at different orientations and where they are meeting. That is not practically possible. For small experimentation we can do such thing, but practically it is not always possible to find out the center of gravity of a body. The bodies are of small scale to very large scale. That is not possible. So in physics we can verify the laws through some experimentation, but we cannot use the experimentation for finding the results every time. So it is not possible. Here we use our earlier we have dealt this principle, that is principle of moments, or Verinon's theorem. The French mathematician Verinon has given this principle that the algebraic sum of moments of a given system of coplanar forces about the moment center in their plane is equal to the moment of their resultant force about the same moment center. That is, suppose some parallel coplanar, that is in a plane, when we say coplanar, we mean that they are passing through the same plane, they are acting through the same plane. The algebraic sum of the moments of a given system of coplanar forces, that is, when some coplanar forces, that is system of coplanar forces means some n number of forces, when they are acting, the moment center in their plane is equal to the moment of their resultant about the same moment center. So moments about some point, suppose let us say some axis, we have taken some axis. some x-axis or y-axis. So through that, to that moment center, to that axis, if we take the moments of individual forces, that is we have seen, that is individual forces is F1 d1 plus F2 d2 plus F3 d3, so on, we have considered. That is equal to the distance between the resultant F acting at a point D. So we can say the sum of the moments produced by individual forces is equal to moment produced by the resultant force, that is sigma F1 d1 plus F2 d2 plus F3 d3, so on, is equal to total force F into the distance where it is acting. If you see this figure, these forces, let us say this entire body is divided, there are some components, that is W1, W2, W3 are small parts or components. So W1 is acting here, W2 is acting here, W3 is acting here, W4 is acting. If we say, if we take moment perpendicular, this is because they are acting here, the perpendicular distance d1, W1 is at a distance of d1 to this axis, let us say this is some y-axis. If this y-axis, W1 is at a distance of d1, W2 at d2, W3 at d3, and so on up to, let us say, W8. There are eight parts, components. So W8 into d8 will give you the moment. So sum of their moments is, since they are acting in the same direction, they are algebraically added, means W1 d1 plus W2 d2 W3 d3, so on up to W8 d8. And also, if entire this, let us assume that entire force W1, because they are acting coplanarly, their sum will be W1 plus W2 plus W3 will give you, all forces will be equal to resultant W. But the problem is, we do not know the distance of their action. So by knowing that, here the thing is, we assume that we know the distance of d1 from this axis and distance of d2 from axis, but only we do not know the distance d where the resultant is axis. Otherwise, if all are unknowns, that is d1 d2 d3 are all are unknowns, we cannot solve the problem. Only here that once we know what is the weight of individual component and distance of its own point of action, then only we can find out the only one unknown which is left, that is the d. That is why moment due to individual parts at y-axis, that is moments due to these individual components or parts at y-axis is m is equal to w1 d1 plus w2 d2, force into distance 1, second force into distance 2, and all up to w8 d8. This gives the equation 1. But according to principle of moments, if w is total weight, then d is the distance of the total weight from y-axis, then moment is equal to w into d. That is, we are using the Bernoulli's theorem. So from equation 1 and 2, since equation 1 and 2 are equal as per the principle of moments, we can say w into d is equal to w1 d1 plus w2 d2 up to w8 d8. That is, moment produced by the resultant w into d is equal to the moments produced by individual parts, that is w1 d1 plus w2 d2 and so on up to w1 8 and w1 w8 d8. These are the 8 parts. Let us suppose we have divided that entire body into 8 parts. So we know what is w1, that is weight of each part, and also the part through which its force is acting, that is d1 up to d8, d1 d2 d3. Then the only unknown left is here is d, that is the distance of resultant. We know the resultant weight w, the individual weights w1 d2 w1 w2 w3 etc, and we know d1 d2 d3 up to d8. We know only the unknown is d, that is the point through which the entire weight or mass is assumed to be acting. So by knowing the weights of the components and distance of their reaction of weights, d, the distance of center of gravity from the x-axis, can be determined. That is, m into d is equal to sigma w1 w into d, that is total weight into total weight, that is the resultant of all the components, into distance is equal to w1 d1 w2 d2 or sigma w d1 w1 d1. So d, the unknown, is equal to sigma w1 d1 by sigma w, that is the moments due to all forces divided by the entire weight will give you the distance. Therefore distance d can be found out by w1 d1 plus w2 d2 so on up to w8 d8 divided by total weight w. We can say sigma w1 also, because w total weight is equal to sum of w1 plus w2 plus w3, all those things, that is sum of weights. Sum of those 8 weights is equal to the total weight. So here d is equal to sigma w1 d1 by sigma w. That is also we can say, either we can say sigma w1 d1 by w or capital total weight, or sigma w1 d1 by sigma w1. That is either in either way. What is when we say sigma w, we mean that it is the total weight w. So here let us see a small analogy to demonstrate the Verinon's theorem or principle of moments. That is, to find out the center of gravity of a figure. We have seen that whenever there is a UDL or load, we know that it acts through its middle. That is why we have used the word centroid, but we have not stressed on it, because we synonymously use the midpoint of action of point, because we have not learnt about the concept of centroid earlier in our, when we have done the problems about the beams using uniformly distributed load. We discussed that the uniformly distributed load acts through its midpoint. We have not said that it is acting through its centroid, because then the concept of centroid was not known to us. That is why we said that the entire UDL is assumed to be concentrated as the intensity into distance at it at the middle of the or center of the load. That is, if it is the load is applied for a length of L, the weight acts through the half of its distance, that is d by 2. So WL acts at the distance of L by 2. That is how we have solved the problems in cantilever and also simply supported and overhang beams. Whenever we came across the concept of uniformly distributed load, we have found out that their action is through their midpoint. That is how we have solved those problems. Here let us take this analogy, brick analogy. In this concept, suppose there are three individual bricks are placed side by side. So each brick is 100 newtons. Let us suppose they are 100 newtons. Don't calculate what is the weight of a brick. Just suppose that there are some bricks, each brick weighing 100 newtons, that is around 10 kgs. So let us not think about actual bricks. There are some special bricks. Let us suppose this 100 newtons brick has 1 meter length. Each brick is, this is let us suppose this is one brick. This one brick is of 1 meter length and has a weight of 100 newtons. 100 newtons. So these bricks are placed side by side. So we know, since their bricks are symmetrical, this 100 newtons acts through this center of the brick, that is at 0.5 meters. So if we consider, if we take the moments about this y-axis, that is they are acting along the y-axis, along the vertical plane, the distance between this action and the horizontal distance, it is vertically they are acting, so perpendicular distance is horizontal. So 100 newtons is acting at a 0.5 meters. The first brick is acting at a distance of 0.5 meters, that is through its middle. The second brick has middle here, that is another 0.5. But our axis through which we are measuring is y-axis, that is at a distance of some x. So this x from this y-axis, the distance x2, let us suppose x2 of second brick is 1.5 meters, because this is 1 meter and this is half a meter, so 1 meter. Similarly, the third brick center is at a distance of 2.5 meters, that is we have crossed two bricks 2 meters and half of it, that is 2.5 meters. So by taking moments, this will be 100 into 0.5, this will be 100 into 1.5, the third brick will be 100 into 2.5. We are taking moments about some y-axis at the end of the first brick, that is at the left end. So the distance, weight is 100 newtons, distance is 0.5. So we got the moment, force into distance, 100 into 0.5, 100 into 1.5 and 100 into 2.5. That is why the total moment is 100 into 0.5, 100 into 1.5, 100 into 2.5. That is, it is 450 kilonewton meter. Sorry, 450 Newton meter. It is 450 Newton meter. Now consider, instead of 3 bricks, there is a single brick of 3 meters of the same dimension, but they are somehow they are cast in a single monolithic cast, that is they have 3 meters and a weight of 300 newtons. Instead of 30 newton 100 newtons of each, we have cast a single brick in a single piece, that is 300 newtons. So we know of 3 meters, the distance is, the length is 3 meters and the weight is 300 newtons. Then if we see, its center will be at a distance of 1.5 meters, that is half of 3 meters. Now if we take moment about y-axis, the moment will be 300 newtons acting at 1.5 meters, that is we will get 300 into 1.5, that is 450 Newton meters. So it is same as our earlier moment which we got from individual bricks. So here we can say the first result and the second result are same, that is 450 meters. So this is how we can say moments due to individual weights is equal to moment due to total resultant. This is how we can demonstrate the Verigne's theorem or principle of moment through simple analogy of bricks. These bricks we have taken only 3. We can take 2 or 3 or 5 or n number of bricks, but the finally what we get is the moment due to individual bricks is W1 D1 plus W2 D2 plus W3 D3 so on, and moment due to individual only one brick, that is total W into the total distance from its centroid D. So W into D is equal to W1 D1 plus W2 D2 plus W3 D3. So D is equal to, if it is unknown, in this case we know it is symmetrical, therefore it is at the centroid. Suppose it is unknown, then also automatically using that analogy, 300 into unknown distance D is equal to this 450. Therefore D will be equal to 450 by 300, that will be equal to 1.5. This is how this logic, this principle we use to find the centroids. So now we come to the point called the centroid. We have seen in for three dimensional bodies which have weights, they are called the point through which the weights act are called center of gravity. But in case of centroids, because we are solving on paper and we are using only plain figures, then we assume that the figure is plane. Therefore, there cannot be any z direction. So we are finding the centroid in two-dimensional thing. Suppose if we consider that entire body which we have seen as a three-dimensional body of length, breadth, and some thickness. This was the body earlier we considered. We have taken only parts of this. But if we go on decreasing the thickness, this thickness as it tends to zero, then the body becomes a plane instead of a three-dimensional body which is having some thickness. When compared to length and breadth, this thickness is very small. Even if I decrease further, then it becomes a plane, that is a plain paper. So we can say when we compress a three-dimensional body to so that the other dimension is approaching zero, then that body becomes two-dimensional. Actually, in in actuality, the paper is a not a two-dimensional body. It is a three-dimensional body because it has length, breadth, and also the thickness. The thickness may be very very small, but even then it is a three-dimensional. But on a surface, when we represent only two-dimensional, there is no three-dimensional. That is why here, from the principle of movements, we have seen WD is equal to W1 D1 plus W2 D2 up to W8 D8 in our previous example, where we found out the center of gravity for the three-dimensional body. Therefore, the distance of center of gravity is D is equal to W1 D1 plus W2 D2 W3 8 by W. But here we know the relation W, weight is equal to R, unit weight of a body is weight by unit volume. That is, for any body we take the entire weight divide by volume, then we will get the unit weight, what we call it as weight density. So here if we say weight density gamma, then gamma is equal to W into volume, W by volume, weight by volume. Therefore, weight is equal to unit density into volume. So therefore, in this equation, if we substitute W with gamma V, that is density into volume, then we get M is equal to weight into D. Instead of weight into D, we are substituting gamma into V. So gamma V into D is equal to